Thank you, everybody, for coming out this afternoon. It's been a great conference so far, and we at Kazina are very excited to share our story with you. So without further ado, today I and my coworker Levan will both be presenting. I'm a senior engineer at Kazina, and I've spent several years automating the deployment of Hadoop clusters on AWS and Azure. And after about half the talk, I'm going to hand the baton to Levan, who directs product at Kazina. I'm going to start with a quick overview of the near real-time project that we started and its specifications, talk a little bit about cloud architecture of the Hadoop cluster that we deployed and how that connected to the enterprise, and summarize with some performance metrics that we took towards the end of the near real-time flow and conclusions and, I guess, further add-ons to the project. Then I'm going to pass it to Levan, who is going to talk a little bit about the enterprise cloud opportunity more broadly and best practices and tips and tricks that we've learned over the past several years of automating deployments in the cloud. And of course, we will leave a few minutes at the end for Q&A. But before I dive into the serious stuff, I myself am a new parent, and I have a 9-month-old. And in writing this presentation, I've thought a little bit about the similarities between a big data project and raising a 9-month-old. So one is you're in it for the long run, and whatever decisions you make, you are going to live with for a long time. So you should take that into consideration. No matter how small your project starts, you will need to plan for frequent doubling in size of the project. And as a result, whatever equipment you started with at the beginning is going to quickly become out of date. And unfortunately, somebody's going to have to get up in the middle of the night with some frequency in the beginning, and hopefully you'll get to sleep through the night more later on. And as the photo shows, things can get a little messy. But of course, it's all worth it. In the end, you'll be amazed at how much progress can be made in just a short period of time. So to start in on this more enterprise-oriented story, we had a client that we'd worked with in the past come to us. And this client believed in the big data story and believed that they could realize significant return on investment based on big data projects. And it actually outlined 10 different big data projects that they wanted to implement. And they'd already bought a Hadoop cluster and had it implemented on-premise with on-premise hardware. And there was just one problem with the whole story, which is that the Hadoop cluster was broken. It had been broken for several months, and it was not in a functional state. So they came to us and they said, well, what can we do? And we said, OK, we're going to put our heads together, and we're going to pick one of the 10 projects you have. We're going to put a short timeline on it of 2 weeks so that we're both focused. We have focus on both sides, and we can show strong value in a relatively short time frame. We're also going to make sure that this solution can serve multiple teams within the enterprise as one of the requirements. And the last point is that none of these specifications would make any sense without a cloud-oriented mindset, right? You can't have a 2-week time frame if the first step of the project is shipping physical hardware to an address. And once you lose the 2-week time frame and you have a multiple-month time frame, you can't actually pitch a data-driven project in which you only really get one thing done. The project grows. So this whole sort of agile, quick turnaround type methodology is only possible with a cloud-based Hadoop cluster. Can anybody tell me what this is? Sometimes this photo comes up at conferences. Yes?
Google 99 first production server?
That is the correct answer. So it's a bit of an eye chart, but you have very good glasses. It's in the URL. It says first production server. So this is Google's first production server. So it's from the late 1990s, and I think it's interesting to start off with this photo because I look at it and I think, well, here's a company that's betting on cutting-edge technology, and they're putting together a pilot project with the belief that potentially in 5 or 10 years, their entire industry will be transformed based on their technological bets and their technological edge. So I sort of asked myself the question, what are the pilot projects, or what are the projects that my organization could be doing that can drive similar advantage or similar change in my organization? And that's sort of what this talk's about. So to talk a little bit more about the one project that we decided to work on with this client, the client is a large enterprise with several $1 billion in revenue, and they had a call center. And the call center ran software that's called interactive voice recognition software, IVR software. So every person in this room has interacted with IVR software. When you call an airline and a machine asks you questions and you respond and it understands your responses and takes you through a certain flow, you are interacting with an IVR system. So the client received data coming out of this application in batches. And a batch is basically, how did the last set of calls go? And the client wanted to optimize the performance of the IVR system so that they would know how successful the system was in responding to customers' requests. So we needed to design a system that could load data every hour into a cloud-based Hadoop cluster, and the system needed to be able to support about 10 gigabytes a day with certain spikes in demand. And the reason that the near real-time flow is sort of essential in this case is that some of the insights that could come out of the system lose their value over time. So if call quality is dropping and customers are dissatisfied with the performance of the system, that's an insight that might matter if you can discover it within an hour. But if you only discover it the next week, then there's not a whole lot you can do to respond to that incident. So one of the themes of this talk is what can you get done in a short amount of time? We have a 2-week deadline. So what did we omit? Sometimes people would raise their hand and say, hey, can we test 2 different cluster configurations? And the answer is no. We're going to prioritize this project, and at the end of the 2 weeks, we can assess what we want to do next, but we need to keep the scope of the project in line. So we did not test different sizes of Hadoop clusters in the cloud, even though it would have been relatively easy to do so. Our client ultimately wanted to store data on cloud object storage for 7 years to meet auditors' requirements. But again, we left that out of scope and as a potential add-on for later. The load of data into the cloud was not parallelized, and we did not spend a lot of time or resources making components of the pipeline high availability. It adds a lot of complexity and a lot of cost. So this is the configuration of the actual cluster that we deployed. Some things to note on this slide. This cluster is deployed on Microsoft's Azure platform. The cluster has about exactly six Hadoop worker nodes. Across the 6 nodes, we have 120 cores of compute and just under a terabyte of RAM at our disposal purely for compute jobs. That does not account for the name node and the resource manager and the nodes that are sort of running the cluster. And we attach about 50 terabytes of storage to the cluster so that we have space for files going forward. This next slide sort of shows how that Hadoop cluster connects to the enterprise. So we place a virtual machine on the enterprise client side. That virtual machine sits behind the enterprise firewall, and that virtual machine creates a VPN tunnel that connects to the Hadoop cluster, which lives in the cloud, so that all data movement between enterprise and cloud is secure. And the client has a couple of ways of accessing the cluster. One is at the end of the day, we basically handed them some Python scripts, and they ran some Python scripts on their side with a cron job that did the data load into the cloud. 2 is they had access to several different Hadoop-based web UIs so that they had some visibility into what the cluster was doing and how it was doing. This slide sort of shows the flow of data from the enterprise into the cloud. So we start on a node on the enterprise side with the call log files. That node will hit the web HDFS REST API, and upload data to HDFS. Then we run a Spark SQL job that does a lot of ETL, extract, transform, load jobs, filters the data, splits it into different tables, and does a conversion of format into a format called Parquet format, which can perform much faster for certain ad hoc analytic query type loads. And then we ask Impala to build the final table, and we allow Impala to run its workloads a little bit faster by doing something called compute stats. And we take the sort of Spark SQL plus Impala job, and we wrap it in a job scheduler called Uzi. And it's very easy to say, OK, Uzi, please run this Spark job, and then please run this Impala job, and please do all of that at this interval. And of course, at the end, we have these final sort of ready-to-use process data sets. Initially, those data sets are going to be queried by data scientists who are running Impala queries, but we also have the ability to add in some Spark ML lib scripts, et cetera, which I will talk about later. This slide sort of shows the unsung hero of this whole workflow, which is Python. We were able to get a lot done because Python scripts can drive almost every part of this job. So we had a Python script that drove the periodic loading of data into HDFS. Then we had another Python script that kicked off the Spark ETL job. We had a set of SQL scripts that drove the Impala jobs, and the Uzi workflow definition was contained within 2 XML files. And of course, we had a small data sample from the client, which allowed us to run and test these scripts beforehand, before sort of passing the scripts to the client side. So once we'd written the scripts and tested them on the Kazina side, we basically handed the scripts to the client side and allowed them to do a live run on live data for a 24-hour period. And we took a lot of metrics during that time so that we would know what we might want to change going forward. So the sort of good news here is that even under peak data load, the system did not back up. We didn't have our jobs running into one another. And we also have pretty good visibility. You can see how long the data upload took, how long the Uzi job takes, how long different steps of the Impala job took, and how the data is growing over time. So unsurprisingly, there aren't as many calls to the call center coming in late at night and early morning. So that was sort of, that last slide was sort of, that was a slide where our blood pressure went up a little bit, and we're doing a live demo. How's this going to go? And it went pretty well. The client was pretty happy with it. And after that, we had time to discuss, and we actually had 1 or 2 days left in the 2 weeks to discuss, well, what else can we do with this? And one of the additions, which I mentioned earlier, was the use of cloud object storage. So cloud object storage, well, cloud architectures are a little complicated, but the reason that we would want to add in cloud object storage to the workflow is that it is 5 times cheaper than our local HDFS storage. So when storing a large volume of data for a long time, those cost savings can really add up. And the question that we wanted to ask, and our client was asking, was, if we add in cloud object storage, will our pipeline back up? Will it break our pipeline? Will things go terribly wrong? And we had to do a little performance testing to find the answer. So the test that we do here is we took a section of the pipeline. So we take plain text files that are compressed, and we convert them to our Parquet format, and then we write the end Parquet data set compressed to HDFS. And the sort of comparison we're doing here is, when the source data lives on HDFS, is this job faster than when the source data lives on object storage? So does object storage slow things down? So the top table and the bottom table are absolutely identical, except the top table has source data on HDFS, bottom table has source data on BlobStore. And in the first run of the job, which is a Spark job, we see that the top table takes 5 minutes to run. So when source is HDFS, job runs in 5 minutes. When source is Azure WASB, Azure Blob Storage, the job takes 15 minutes. So we see that the job is 3 times slower on object storage, which is not a good result. And we're thinking, look, we've got 120 cores, and we've got 6 different nodes attacking 1 gigabyte of data. Like, what's it doing for 15 minutes? And the answer is that Spark is really smart, but it only does what you tell it to do. And in this case, Spark was not able to take advantage of all 120 cores because it didn't have great opportunities for parallelism. So our performance tester, who could raise her hand if she wanted to, yeah, is in the audience, made a couple of very smart tweaks to the Spark job and basically got it running in 1.2 minutes, regardless of whether the source is HDFS or object storage. So this is a very good result as far as what we could present to our client, right? Because we can say, look, yes, we can take advantage of the storage that's 5 times cheaper, and once we've optimized the job just a little bit, there's actually no performance penalty. So this it's really paid off. There were a couple of other additions that our client wanted to discuss in the 1 or 2 days that we had extra. So one point is, wait a second, we've got our own data already processed in the cloud, and a data scientist on the client side said, I've got these scripts that run some machine learning analyses using Spark MLlib on that data. So what if I tested those scripts on the cluster? So he loaded his scripts onto the cluster, and he pressed the submit button. And of course, we all know what happens then, right? We get lots and lots of errors. We get each node spewing lots and lots of red lines of code and sort of aggregating it and packaging it together, right? So my phone rings and I take a look, and we needed to install 2 Python packages. And once those Python packages were installed, the scripts ran with no problem. So that was sort of a nice extra. We thought that we were just going to get 1 out of 10, and we got 2 out of 10. It's a good feeling. And then another possible add-on that the client had discussed was they had a streaming application, and the streaming application currently streamed to the enterprise. But they said, wait a second, we want this data to live with this other data anyways. Why don't we just save ourselves a headache and have that data stream right to this cloud-based platform? For all we know, the streaming data is already coming from like an AWS or Azure cloud, and they're both sitting in Virginia, so it could be a much more efficient transfer of data. And I'd say the most important takeaway here was probably that the client had started after maybe hitting a stumbling block in the big data world, right? Hadoop cluster was broken, it's not a great feeling, right? And we were able to take a couple of discrete use cases and in a very short time frame start to build or rekindle some of the excitement that can come from a big data project and the insights around it. So for those of you who like a lot of detail on NRT workflows and the exact steps, these slides will be online, and you can go look them up after. I'm not going to get into it now because we don't have quite enough time. And for those of you who enjoy this talk and would be interested in further resources, we did a great session with RStudio last week, in which they did a very good job of showcasing RStudio, R scripts, and how R can interact very well with Spark on a Kazina platform. And we've also got some nice content on our blog on choosing Hadoop infrastructure, et cetera, et cetera. And with that, I'm going to pass the baton to Levan. You'll note that I didn't mention a lot of things like how did we encrypt the data on disk and how did we Kerberize the Hadoop cluster. And the reason is that all of that was included with our Kazina platform. So Levan's going to talk a little bit more about that and other tips and tricks for cloud-based deployments.
Thanks, Dan. So I think one of the things, as running product management that I see and really struggle with all the time is that, this space is just changing so quickly, right? And I think it impacts all enterprises as much as it impacts companies like us that produce solutions, right? There's more and more data sources, there's more and more complexity just because this landscape is changing so rapidly. And then you add in cloud into the mix, and this is not really a problem for companies that have grown up in the cloud, right? So if you're a Netflix or a Facebook or Google, the only world you know is the cloud world, right? So that bubble kind of disappears, right? But if you, like most of the other organizations around, you started pre-cloud world. You have a whole bunch of data that sits in the cloud, that doesn't sit in the cloud. You have tools that don't sit in the cloud. So how do you start to take your enterprise stuff, leverage the cloud, but not break any of the compliance and processes that have been built up over the decades within your organization? Right. So we tend to look at it as there's a couple of best practices that we follow at Casino when we build stuff, and we think that those best practices are reasonable for lots of people to follow, whether they're using a platform like ours or building their own. And the first one is to think about it as a platform. We speak to lots of companies where we find little pockets using the cloud, right? So somebody's built a little application over here, and somebody else has built another application, and then you look at it, and there's very little commonality between them. They have to be managed independently. It's the same data that's sitting in the two places. One has security, the other one doesn't have security. So thinking about it as a platform becomes really important. The second bit is, which I think is one of the hardest problems to solve, is how do you integrate that cloud into your existing enterprise, right? So you've got all of this existing stuff, but the cloud's out there, right? So if you make it secure, how do you securely integrate it in? And though that securely integrated in is a whole bunch of technology, but then you also then need to think about compliance, right? Because just like you have tons and tons of compliance for your on-premise stuff, you need to figure out how I apply all of that compliance now to this totally new paradigm that doesn't quite work the same way as physical stuff sitting in a data center. And then once you have all that compliance, you then need to manage and operate it. And you need to manage and operate it just like all of the other enterprise assets that you have, right? And then the last bit is trying to figure out the cost model, right? I think the cloud is great when you look at it from the price sheets and you see, oh, look, this machine cost me 2 cents an hour, right? But once you start doing these large-scale things, I mean, that cluster that Dan was talking about, costs a couple of $1,000 a day. So you can very, very quickly run up some really high numbers if you're doing things at scale. So using some clever techniques to manage those costs, which the cloud allows you to do, they just don't make it very obvious. Right. So let's just drill into each one of those, right? So the first bit is that I think all of the cloud providers are really good at giving you lots and lots of tools, right? But they don't give you an overall platform that solves a problem, right? So one of the key things to do is to start to look at how do I take all of these different tools and then build a platform out of it. And the tools that you're going to get from each of the cloud providers is a little bit different, right? At a high level, they have a lot of similarities, but once you delve down into the details of security or different kinds of storage, there's some vast differences between them. So you really want to start to leverage the best of breed from all of these providers. You want to do the same thing at your data management layer, right? I mean, you all are doing analytics, but I guarantee you that if we ask people what kind of analytics they're doing, they're all doing slightly different kinds, right? So you want to make sure that as you're building this, it's not optimized for just one particular kind of analytics. It's not just interactive analytics or iterative analytics or batch analytics. You need something that can do all of that. And then you need something that can cater for that pipeline, because you're always going to have to interact with the on-premise portion of it. So taking just a little slice of just data movement, right? I've got data that could be on the cloud, but I've also got my on-premise stuff. So how do I securely ingest it onto this platform, right? And that ingestion could either be batch or streaming, so I have to cater for both of those things. I typically want to use object storage, like Dan was mentioning, because of the cost advantages there, because of the resiliency of it. But object store is not a panacea, right? So if we take AWS, for example, S3 is not consistent, right? So what does that mean? That means that if I want to run a quick iterative process without consistency, your iterative process is going to break, right? Which means that you then have to augment your object store with some sort of other storage that either has consistency or has low latency because of what you're doing. Right, so you've now got multiple kinds of storage. So how do I manage all of this? Across that multiple storage, if I've now got multiple processing engines, so I've got I've got Spark, I've got regular MapReduce-based things. All of those need to be able to access all of these multiple storage layers consistently. And then there's particular kinds of things that are going to cause you to optimize for a very particular kind of use case. So I chose interactive analytics here because generally what you need here is you need to have a system that can do very, very low latency and high concurrency. Right? So how do you do all of this? You can't look at it as siloed, right? You have to look at it as a platform. And then once you have that platform, how does that platform integrate with my existing on-premise stuff? So again, this is what I mentioned. This is not a problem if you've grown up in the cloud, right? Because you don't have an on-premise footprint. But if you do have an on-premise footprint, how do I ensure that I can have frictionless movement of data from an on-premise system, which is behind a firewall, right, and not accessible to the internet, into the cloud, which is now a secure cloud that has no endpoints. Right? The same way I have all of these tools that live on my desktop, right? So I might have a visualization tool that lives on my desktop. How does that tool now connect to this cloud platform, right? I need to be able to solve that problem to have a secure connection up into the cloud. And then how do I now start to share data, right? And that's sharing data not just within teams within an organization, but more and more we see companies starting to share data with their business partners. And so again, a simple example where moving data into the cloud is not so simple, right? I have the most simplistic example, which is I've got a CSV, right? I've got a simple CSV file, but depending on what processing engine I'm using, the format of the file that you need needs to be different, right? If I'm using Impala, like we have in the Casino platform, then Impala really likes Parquet. Right? But if you decided, well, I prefer Tez to Impala, then you better be storing your data in awk. Right? And if you've decided that you want to use Apache Drill, then your data better be in JSON. Right? But that's the same original file that now needs to be in all of these multiple formats if you really want a high performance system. Right? So movement of data is not just about taking the bits and moving it from point A to point B. Right? You need to be able to move it from point A to point B and ensure that it's in the optimal format so that you can get the performance that you need. Then there's the big elephant in the room, right? There's a lot of perception that the cloud is not secure, right? And I think that that's predominantly perception, right? The cloud, all the cloud providers give you lots and lots of tools to make the cloud just as secure, even probably at some cases more secure than anything that you can have on premise. But those are just tools. How do you stitch them all together to get a really secure system, right? So the approach that we tend to take is, even though this is all public cloud, you can turn it into private cloud, right? There are techniques in which you can take the public cloud and turn it into a single tenant private cloud. Right? One example of that is you ensure that there's no public IP addresses. Right? So everything you spin up in the cloud has no public IP addresses. You mandate end-to-end encryption. Right? So in this case, you want to build something where you're not relying on an individual developer to tick the encryption box. Right? You want to ensure that all of your data that's living out there is encrypted. Right? So there needs to be mandatory encryption in motion, mandatory encryption at rest, and that encryption now needs to go across all of the storage formats that you have. Once you've got the big wall, right, which is the private cloud, you've got everything encrypted. You still want to now control who gets in, right, and what they get to see once they're in there. Right? So everything needs to have role-based access control. And even though you have all of those layers, you need to make sure that you're still logging and auditing everything, right? Because at the end of the day, things always go wrong. These are humans involved in building all of these things. You need to be able to ensure that you have an auditable way, especially if you're in an organization that has to follow some level of compliance. right? So taking that same data flow again, simple example here of just one little slice of encryption, right? How do I move on-premise data securely into the cloud? So you're going to have to set up some sort of VPN technology to do that. You have to now do your object storage and ensure that all of your object storage is encrypted, right, by default. If you're using any sort of low latency to deal with the consistency problems, you have to make sure that you encrypt those disks. Once the engines start to access all of this data, you have to enable them all with Kerberos, right, and ensure that you have a ticketing mechanism that can hand out the tickets effectively. Above all of that, you need to have user authorization, right, so that the right people can go and process only the data that they're allowed to process. And then once you get to interactive analytics, it's the same thing. Only the right people need to be able to see the data, and I need to deal with all of the encryption at rest, again, because I'm now using low latency storage to be able to do that. Right? And then if I want to pull that back on premise to be able to feed it into other systems, I need to be able to securely encrypt that data and move it back on premise so that I can do that. Right? And then on top of this, you have to now do all of the key rotation and key management, right? Because each of those encryption keys needs to be managed and rotated and stored in a secure way, right? So it's all possible to do. All of the tools are there, but you have to make sure that you do it at every single step of the process. Right. And so once you have all of that, then you've now got a system that's up and running. You now need to be able to manage it, right? Because you have to keep the lights on. If this is a production environment, there need to be all the same production processes with it. The step one of this is ensuring that you're centrally logging everything, right? And there's lots of components now to log, because you need to log all of the cloud components. You need to log all of your data management components. You need to log all of your data movement components. You can pull all of that together. And once you have all of that data, you can now start to feed the operational management systems, right? So you can feed your SIM if you're doing security processing, real-time security processing. You can feed all your system management things, for keeping the lights on. And you want to expose all of that via a nice set of APIs, because there's lots and lots of people that are going to use that data for different things, right? Including auditing functions. And again, the idea of why you want to do this is because there's so many different consoles, right? If you wanted to use all of the native stuff, because we always hear, oh, but the cloud providers give us this already. And it's like, yeah, they kind of give it to you, but you have, one console for AWS, and if you've decided to put in a Hadoop distribution in there, you've got another console for that. And then if you've got a key management solution, you've got another console for that. And so there's all of these consoles all over the place, right? So that's the reason that you actually want to put the effort into doing centralized logging, right? Because when something goes wrong, there is no way that you're going to go to 4 different consoles to try and stitch together, what happened when somebody tried to move a piece of data, from outside the cloud into your cloud, and then some process failed, right? And then the last bit is make sure that you don't leave your credit card at the bar, right? Because you're going to get a really big bill at the end of the night. So the key here is to come down to, how do I figure out on a continuous basis that I'm getting the best cost performance, right? So that means that I don't want to have compute resources that are too large for what I'm doing, right? Because if they are, I'm overpaying, right? I don't want to keep stuff up when it shouldn't be up, right? But all of that needs to be driven by what my SLA is, right? So the business level SLA needs to drive your entire cost optimization, right? Because for what Dan was talking about, their SLA there was 15 minutes, right? So the fact that that cluster cost, a couple of $1,000 a day was okay, because if they didn't meet the 15-minute SLA, right, they'd lose even more money than that, right? So the driver for the costing starts at what's my business level SLA, and then you can work backwards and build a whole range of tools if you want to build those tools to try and now start to manage the cloud from a cost perspective, right? Because I've now got a production level cloud, but I now want to start to manage my costs. And then you want to build all of the other things that would keep all of the configurations, right? So you've now got lots of configurations. I mean, in the Spark environment, what is it? Something like 1,000 configurations between HDFS and Yarn and Spark, right, easily. You don't ever want to lose those once you get them right. So So you need to make sure that you have good, consistent backups of all of your configurations. Don't store them in the same cloud, which is why we had 2 different clouds up there. And you want to then build all of the processes that will monitor that end-to-end SLA. Right? And of course, that's a point in time, right? So hopefully, as you're building all of these things, your analytics are successful, people are going to put more data on there, they're going to put more analytic processes on there, and your requirements for what the platform needs to do is going to change, right? So you need to build elasticity into every layer of that, because you might need to just grow your compute without growing any of the storage. You might need to grow some of the storage or use totally different kinds of storage. So the platform needs to be able to do all of that. Right. So, how do you do all of that? You can build it from scratch, right? I mean, this is what Googles and the Facebooks and the Netflix of the world do, right? They have thousands of engineers, and they're able to do these things from scratch. There's technologies now that would give you, Hadoop as a service or a data warehouse as a service. So there's one component that is managed for you. You're going to have to build all of the encryption and the integration around that. Or you can take something that's more turnkey, right? And the more turnkey would be a data platform as a service, right? So there's somebody else that's dealing with all of the platform that performs the compute and performs the storage, and you just rely on data and analytics. So that would be the shameless plug for Kazina, because that's what we are. We're a platform as a service. And so you can think of us basically as a very secure platform on which we run on either Amazon Web Services or Microsoft's Azure, but you never actually deal with the cloud. Right? We abstract the cloud away from you, and we give you an analytic platform on which you can run a wide variety of analytic workloads, including some of the really popular tools like RStudio. Right? So it's all just built into the platform so that you have easy capabilities to be able to move data on and then do your analysis. Right? And we take care of all of the boring bits, like making sure that everything runs. We do all the upgrades for you. We keep the lights on, and most importantly, we maintain the security and the integrity of the environment. And we're looking for people. So if anybody thinks that they'd be interested in helping us build this platform, come and see any of the Kazina people afterwards. We've got a whole bunch of open positions, and we'll use the last 10 minutes for some questions. Any questions? No? Good. So if any of you are interested in actually putting your hands on a platform like this, come and see us. We've got a booth out there. You can, we have environments on which you can, start loading some data and doing some analysis. So thank you for your time.